Greetings and welcome to your geometry recording for the week of October 24th. This is also week 11, so make sure you're working in the correct folder, and more importantly that when you go to do your key phrase assignment, you're doing it for the week of October 24th or week 11. I do have a warm-up question for you guys to get us thinking about parallel lines and slope. So we are going to be finishing up Unit 2 this week and moving on to Unit 3. And the first session in Unit 3 deals with lines and slopes of parallel and perpendicular lines. So I want to get us thinking back to algebra, pre-algebra times, where we focused on slope of parallel lines and perpendicular lines. So a warm-up problem to get us thinking in terms of slopes are below, and what you need to do is look at the two lines and determine if those two lines are parallel lines, and then tell me how you know whether or not they are parallel lines. So tell me if they are parallel lines, and then how do you know? So go ahead and click pause. I do want you to complete this in your math notebook on your own, and then when you're ready to check your work with mine, go ahead and click play. All right, so we have these two equations, 3x plus 8 equals y. And remember, we want to get our equations into slope-intercept form, which remember is y equals mx plus b, so that we can determine the slope. Because we want to find the slope of these two lines so that we can determine whether or not these are parallel lines. So when we get our equation into y equals mx plus b, which is slope-intercept form, then whichever number is being multiplied by the x term, or our m, is the slope of our lines. So again, the first thing we want to do is get our equations into slope-intercept form. I look at this first equation, and it's already in slope-intercept form. Y is at the end. We have mx plus b equals y, which is fine. So what is the slope in this first equation? Remember, it's your m term, the number being multiplied by x. So here, the slope of this line is going to be 3. That's the slope of this line. What about that second equation? So we've got 2y minus 6x equals 8. Is that in slope-intercept form? No. So what we need to do is solve for y, or get y all alone on the left side of the equation. So I'm going to start by adding 6x to both sides. And then on the left, I'm left with that 2y equals 8 plus 6x. Those aren't like terms, so I cannot add those together. So they're just going to be left as 8 plus 6x. And then my last step is to divide the left side by 2. And then I'm going to divide each term on the right side by 2. I'm dividing each term by 2. Doing it to the entire equation. So 8 divided by 2 is 4. 6x divided by 2 is 3x. So now my equation is in slope-intercept form. If I want, I can rearrange that right side so that, let me do that over here, y equals, I can put the 3x term first, followed by my y-intercept, the b term, remember, or my constant term represents the y-intercept. So what is the slope in this equation? What is the slope? Remember, it's that number being multiplied by the x, so here the slope is equal to 3. So remember, our slope back in this other equation was also equal to 3. What is true about lines that have the same slope? Lines that have the same slope are going to be parallel. So remember, lines with the same slope are going to be parallel. So these two lines are in fact parallel because they have the same slope. So they're going to be parallel. While we're talking about parallel lines and same slope, let's talk about perpendicular lines really quick, because this is also from, I believe, Unit 1, Session 3, what you guys are going to be learning about. So, perpendicular lines. So, parallel lines, remember, lines that never intersect, right? Parallel lines never intersect. Where perpendicular lines, let me get a fresh new page here. Perpendicular lines. What do we know about perpendicular lines? They do intersect. So perpendicular lines intersect at a right angle. So perpendicular lines intersect at right angles. They're 90 degrees. Whoops. Right angles, I meant to put, we know that's at 90 degrees, a right angle. So the slope, do you remember what's true about the slope of perpendicular lines? So the slope of perpendicular lines will be opposite signs, and they'll be reciprocals of one another. Hold on a sec. So what do I mean about that? So an example, let's say line 1 has a slope that is equal to 2/3. That means the perpendicular line, or line 2, the perpendicular line, would have a slope of opposite in side, so it's going to be it's going to be negative, and then a reciprocal, we just flip it upside down. So that is what the perpendicular lines, the slopes would look like. They need to be opposite signs, so one positive, one negative, and then reciprocals of one another. All right, so I got a little ahead of myself. So some reminders for this week. Make sure you're checking your grades tab frequently. Look for missing assignments. If you have any missing assignments, submit those. Look for assignments that maybe you started but you forgot to finish. Those would be considered missing at that point then, so get those submitted. And then make sure you're messaging me when you submit missing assignments. So again, I don't have a late form. All you need to do is just send me a message that says, hey, Ms. Cole, I completed this assignment, or I redid this assignment. Remember, I'm only accepting redos from Unit 2. So only accepting redos from Unit 2, and this is also going to be the last week to submit redos. So this will be the last week to submit redos from Unit 2, because we're moving on to Unit 3 this week. So what are we doing this week? You're going to be taking the Unit 2 test. I have added some review, some practice tests. So take advantage of those. Those are optional, but it's a great way to help you prepare for the Unit 2 test. Doing redos is a fantastic way to help also prepare for the Unit 2 tests. This is the last week to submit redos from Unit 2 since we're moving on to Unit 3. So this week after you take the Unit 2 test, you're going to move on and look at Unit 3 Session 1, which is about lines and slopes, which we've already covered most of what that's all about in our review there that we started with, our warm-up, and then I went into talking about the slopes of parallels and perpendicular lines already. And then reviewing systems of equations. I know we've already done this before in prior math classes, so actually 1 and 2 should be a lot of review for you this week. And let's jump in and take a look at what we're going to cover in those first 2 sessions. So slope and parallel lines, let's take a look. So we got a good review at the warm-up question to get us thinking about parallel lines, the slopes of parallel and perpendicular lines. But in this question, we are focusing on parallel lines. And we know that parallel lines will have the same slope. So take a look at this question below, and it actually should be to which lines. Which line or lines are or is parallel to the line with the equation. So there could be more than one correct answer is what I'm trying to get at. There might be more than one option. So take a look at this question, and if you want to try this on your own first, go ahead and click pause now and try the work on your own. Otherwise, I'm going to go through this right now. So again, which line or lines is parallel to the line with the equation? So we're focusing on this equation right here. Y equals negative 2x plus 5. So what is the slope of this line? So remember, the slope is going to be the number multiplied by your x. So the slope of this line is going to be equal to negative 2. So in order for another line to be parallel with this line, it has to have that slope of negative 2. So let's look through here at our options. So the first option is that line AB, another line that would be parallel, would go through these 2 points, A, which has coordinates 2, 3, and B, which is coordinates 1, 1. So we need to figure out what the slope of this line would be. So remember, when you're given 2 points, to find the slope, you find the change in your y coordinates, subtract those, over the change in your x coordinates. So here, if we're finding the change in our y coordinates, I'm going to do my second coordinate first. So it would be 1 minus 3, and then my x coordinates, I'm going to do 1 minus 2. And when I do that, I get negative 2 over negative 1, which turns out to a positive 2. So in this case, our slope is positive 2. And our slope up here was negative 2. So this would not be an option. What about option G? G already has the equation written out in slope-intercept form, so we can easily identify our slope. So the slope in this line is equal to negative 1/2. That is not the same as negative 2, so those would not be parallel lines. What about option H? So here our equation is in standard form, so we need to rewrite it in slope-intercept form. So I'm going to start by subtracting 4x from both sides. And then I get 2y equals 10 minus 4x, divide each side by 2. Remember, I'm dividing each term on the right by 2. So 10 divided by 2 is 5. Negative 4 divided by 2 is negative 2x. And that's it. What's our slope? I kind of already underlined that. So the slope in this equation is negative 2. So it's the same. And, whoops. So our slope is the same. And what about our y-intercept? So here the y-intercept was 5, and here it's 5. So this is actually the same exact equation, isn't it? If I rearrange this, I would have negative, if I put my slope first, followed by my y-intercept. It's the same exact equation as this one. So because it's the same equation, that means this is the same line. So these two lines actually would not be parallel to one another because they're actually the same line. So this would not be an option. So that leaves us with the last choice, J. And let's see here. We've got x plus 1/2 y equals 1. Let's get this into slope-intercept form. So let's subtract the x from both sides. I'm kind of running out of space here. 1/2 y equals 1 minus x. So to get this 1/2 to go away, we've got 1/2 y. We're going to multiply it by its reciprocal. And the reciprocal, remember, is when you flip something upside down. So the reciprocal is going to be 2. So we're going to multiply both sides by 2. We multiply the entire equation on the right side by 2. So we're going to have to distribute. So then we've got y equals, what do we have here? 2 times 1, which is 2, and then minus 2x. I distribute 1 times 2, x times 2. Distributing. I can rewrite that so my slope is in the front. So what is the slope of this line? It's equal to negative 2. And then our y-intercept is 2, so it's not the same line. So this would be the correct answer. There's only one choice here, and that would be the answer. So remember, H, although it has the same slope, it also has the same y-intercept, which means it's the same line, and we were asked about parallel lines. All right, I'm moving on to the next slide. So that was a great review of slope and trying to find slope given 2 points, rearranging equations so that they're in y-intercept form so that we can easily identify our slope. All right, so Unit 3, Session 2 goes into systems of equations. So remember, a system of equation is a collection of 2 or more equations. Here's an example right here. We've got 2 or more equations with the same set of unknowns. So I've got x and y in each of my equations. So we have 2 or more equations, and what we're trying to do is finding a value for each of our variables that when we plug them into both equations, they work. So we find a value of x and a value of y that when we plug them in, they make both equations true. So looking at this example, the solution would be, and we always write our solution in coordinate form of like x, y here. So our solution of these 2 equations would be 1, 5. So let's plug it in and make sure that that works. So my x would be 1 and my y would be 5. So my first equation is x plus y. So I'm going to substitute in 1 plus 5. It equals 6. So that's a true statement. What about the second equation? I've got negative 3 times x. X is 1 plus y. Y is just 5, and it should equal 2. When I plug that in, I get negative 3. Negative 3 times 1 plus 5. Whoops, I do the math. We get 2, and that is a true statement. So you see that this solution worked for both equations. And that's what we're trying to do when we solve for systems of linear equations, is we try to find solutions for both our variables that work in both equations, not just one. So how do we solve? There's actually 3 methods. One method is substitution, and substitution works by solving for a variable. So if you look in this, we've got 2 equations, and we're trying to solve for x and y. So if you have an equation where one of your variables is solved for, like in this first one, we can use substitution. So here I see that y equals 2x. So I'm going to substitute 2x into my second equation where I see y, because I know y equals 2x. So I'm substituting in. I'm going to plug in 2x where I see a y in my second equation. And that way, now I've got an equation set up where I've only got one variable that I'm trying to solve for, because you can only solve for one variable at a time. You can't have 2 unknowns and solve for it in an equation. You can only have one unknown. So now I've only got one x variable, and I can solve for that. So I'm going to start by subtracting each side by 4x to solve for x. I get negative 2x equals 12. Divide each side by negative 2. And I get x equals negative 6. So I've solved for x. I'm not done yet. I still need to solve for y. So what I can do is I can look at my 2 original equations, and I can plug x equals negative 6 into either one of those and solve for y now. But I'm going to choose that top equation because to me it's a lot easier. There's only 2 terms. So we've got y equals 2x. I'm going to plug in negative 6 where I see an x because I solved for x down here. And then I get y equals negative 12. So now I have my solutions, negative 6, negative 12. And you can go through and plug those values in and check your work to make sure you did it right. But we are done. We solved by substitution. So that is one method to solve for systems of equations, is substitution. Let's look at another method. Elimination. So we can use elimination to solve for a system of equations. That's another method. And we use elimination when in order to do it, you have to line up your equations. So we can use it when we've got see how we have them lined up in a column here. Here's my x's, here's my y variables, and then here's equal to my constant terms. They need to be lined up like this in order to use elimination. And when we use elimination, what we're going to do is we're going to add the equations together. So we add the equations together. And the goal is that when we add, we're getting rid of one of our variables. So you want to look for variables that have the same coefficient. So right now I'm circling this right here are y's because the coefficient in each of these would be 1. And then we've got a positive and a negative. So when we go to add these together, look what happens. If we add these two equations together, 2x plus 3x would give us 5x. 1y minus 1y gives us 0. And we set that equal to 9 plus 16, which is 25. So now I have an equation with only one variable, so now I can solve for my x variables. Divide each side by 5, I get x equals 5. And then I'm going to go back and use either equation to solve for y. I'm just going to use the top one, 2x plus y equals 9. Wherever I see an x, I'm now going to plug in 5 so that I can solve for my y. Do the math. 2 times 5 is 10, minus 10 from each side, and I get y equals negative 1. So my solution would be 5, negative 1. So you're going to learn about elimination and how you can use elimination if you don't have two equations with one of your variables having the same coefficient. There's some tricks to get them to have the same coefficient, and you will learn that in Unit 2, Session 2 this week. And the last way you're going to learn, I'm running out of time, so I'm going to let you guys use the lessons this week, is to solve by graphing. Where you'll graph the two lines and then you will find where the lines intersect, and that's going to be your solution. But I'm not going to go over that because I don't want this recording to get too long. So the 3 ways that you can solve systems of equation is elimination, substitution, and graphing. All right, so let me put up, there's 2 parts to your key phrase assignment this week. Let me put up both questions. So the first question you need to answer is, what do you need to do if you submit late, missing, or redo work? What do you need to do? It's important that we review this so that you guys, if you're submitting late work or redos, that you're making sure that it gets graded. And how do you make sure it gets graded? What do you need to do? And then the second half of the question, number 2, the second part, is how do you know if 2 lines are parallel? How do you know if 2 lines are parallel? Directions are below if you need to review how to submit key phrase assignments. Otherwise, have a great rest of your week, and as always, let me know if you need help.